Okay, so let's look at this trig equation. Tan of 2 theta equals 1 over root 3. Okay, now when you're dealing with tan and you're doing the question without a calculator, so we can solve without a calculator, you need to think about the alternative way that tan can be written. Remember, tan of something, if I just put x, equals sine of the same thing divided by cos of the same thing. Okay, so remember, tan equals sine over cos. Right, and what we need to do is this. Well, this is basically, we're trying to find a coordinate out of it, and if you look, it's got root 3 involved, so it's going to be definitely to do with the second circle we looked at, right? It's definitely going to involve this one because it's got that root 3 in there, so it should set alarm bells off. But what we're looking for is, okay, we're looking for sine of something divided by cos of something that gives us 1 over root 3, right? But remember, the x component is cos of the angle that it makes with the x-axis, and then the y component is sine. So we're looking for a coordinate that when we do the the y part divided by the x part, we get 1 over root 3. So where does that occur? Okay, so where does that happen? Is it this coordinate, that one? Well, let's just see. Well, I'm going to... Maybe you need to play around with these yourself, but I'm going to tell you where at least one of them is. Okay, here's one of them. Okay, and the reason why is this. If I take this, which is... Okay, this is sine of that angle, right? Sine of this angle is a half. Okay, so if I take that, a half, and I divide it by the cosine of the same angle, which is root 3 over 2. Okay, if I divide that, remember how you divide fractions, you keep the first one the same, change it to a times, flip the other one. Okay, well, the 2's cancel out, so you're left with 1 over root 3. Okay, so there's one, that's one answer. Okay, so that's one coordinate. So this is actually the angle we're looking for, right? That's the angle we're looking for. Right? I really shouldn't have used theta, but okay, so that's the angle we're looking for. And what is that angle? Remember, this is the second triangle, so these are all pi over 6. So this thing inside here, okay, that thing inside the bracket could equal pi over 6. Okay, could equal pi over 6. All right, well, let's find another one, and then we'll find multiple ones. So with tan, it sort of works in unison that if you find one, if you go along that line, this is the second one as well. So this coordinate, if you take minus a half and divide it by minus root 3 over 2, you get 1 over root 3. Okay, same as this one, because it's a minus divided by minus gives you a plus, and then look at it, it's the exact same numbers apart from the minuses, right? So this is the second angle that thing inside could be, right? This whole thing, the 2 theta, could equal pi over 6, or this new one. So what's that angle? 1, 2, 3, 4, 5, 6, 7. Right, that's 7 pi over 6. Okay, so the 2 theta could equal pi over 6 or 7 pi over 6, but we should work out multiple answers, right? And remember how to work out multiple answers. The tan function is a function that, okay, that repeats, but its period, remember, is pi units. Okay, so what we need to do is just keep adding pi to this. But the thing is, though, if we add pi to... Okay, let me just write this down. If I had pi over 6, if I add pi to that, okay, alright, common denominator, pi over 6, the other one I need to change to 6 pi over 6, okay, and then that will give me 7 pi over 6, right? Because remember, the tan function, its period is pi, right? It repeats itself every 180 degrees rather than 360 degrees, so it's pi we need to add to this. But if I add pi to this first one, I get the second one, right? And if I add pi to that, I go back to, well, I'd go back there. If you look at it, you know, these are on opposite sides of a straight line, so they're 180 apart from each other, or pi apart from each other. So what I should do is just keep adding pi to these and working out the next answers rather than 2 pi. So if I add pi to that, I get 7 pi over 6, but then I need to add pi to that. Okay, so 6 over 6, the common denominator, and 7 add 6 gives me 13 pi over 6. Okay, there's another potential answer. Okay, and then adding another pi. Well, I won't add anymore. Okay, I'll go back to the first one, pi over 6, and I'll take off pi. I'll work out some negative answers. So I'm going to subtract 6 over 6. Okay, common denominator, I'm subtracting pi, but the common denominator, 6 over 6, is the same as pi. So I've got 1 take away 6, that's going to be minus 5 pi over 6, so there's another answer. It could be, let me rub this out. Okay, so it could be minus 5 pi over 6. Okay, and then I'm going to take another pi off that, so minus 5 pi over 6, take off another pi, but common denominator, I need to put that 6 over 6. Okay, minus 5 take away 6 gives me minus 11 pi over 6, so another possible answer is minus 11 pi over 6. And any one of these would satisfy our original equation. But the thing is though, that's not what theta is equal to. This is what 2 theta is equal to, okay? 2 theta is equal to each one of these, right? So 2 times something is equal to pi over 6. So that something is got to be, you divide both sides by 2, I get pi over 12, right? So I need to just basically divide all of these by 2. So theta could be pi over 12, it could be 7 pi over 12, it could be 13 pi over 12, and then doing the negative ones, it could be minus 5 pi over 12 and minus 11 pi over 12. That's basically halving all of these. So that's what theta could be. Okay, let's just check one of them, and I hope the same problem doesn't happen with the last example. And actually, you know what, that last example, I did do it again on my Casio, and it worked exactly. I did get exactly a 0, and I don't know what it is about these Texas Instrument calculators. There's some error with them. Well, let's check one of them. Let's do the 13 pi over 12. Okay, let's check that. So let's do tan of 2 times 13 pi over 12, and let's see if we get, what was it that we wanted? 1 over root 2. Let's go to our calculator. Let's do tan, and in there we want, okay, we just want to put 2 times, in the bracket, 13 pi over 12. I just want to check I'm working in radians. Yes, I'm working in radians. Push across, press enter on that. What do we get? 0.57735. Well, let's just check that 1 divided by root 3 is also the same number. Yes, it is. So it works. That is 1 over root 3. Okay, and then I bet all of these are 1 over root 3. Okay, barring any kind of rounding errors. Okay, so there's an example with tan. So you remember that tan, you have to write sine over cos. So you're looking for coordinates that divide the y component, divided by the x component gives you what you're looking for. Okay, and again, this circle, they're crucial for this, so make sure you learn it.